Kia ora koutou. This video is for Andy and it's a request for a question that is part of an iterative methods problem. So I haven't done that part because that's the usual stuff where you've got to show a change of sign and then find the root of the equation. But the first part of it is quite a nice kind of little bit of calculus and then some algebra. What you've got to do with this question is always just keep an eye on where you're getting to, and we're given the equation of a curve, which is this. So y is equal to x over cos squared of x, and that's for x in the first quadrant. At the point where x is equal to a, the tangent to the curve has gradient equal to 12. So it should be pretty obvious that the first step here is to differentiate, set dy by dx equal to 12, and then substitute in a for x, because it's equal to 12 where x is equal to a. Okay, and then we have to do some rearranging. So let's get on with it. So before we start looking at this, I think this question is far easier if you recognise straight away that that's equal to x times sec squared of x. And now we're going to have the product rule when we differentiate. So dy by dx is equal to the x times the derivative of sec squared of x. So by the chain rule, that will be 2 sec x times the derivative of the inside function, which is sec x. So the derivative of sec x is sec x tan x. Okay, so that's the first part, and now we're differentiating x and we're leaving this. So it's plus 1 times sec squared of x. Right, let's clean that up. What do we get? Well, we get, I'll factorise this at the same time, so we get sec squared of x into 2x tan x plus 1. And we know from the question that when x is equal to a, that gradient is equal to 12. So 12 is equal to sec squared of a times 2a tan a plus 1. Now let's look at where we're trying to get to. It was a bit hard to see here, but you've got to show that a is equal to the angle whose cosine is the cube root of all of this stuff here. And you can see that we've got just cosine and sine, whereas down here we're working with sec squared and tans and stuff. So I'm just going to do some steps to rearrange. And what did I do first? Well, I knew I had to get rid of the sec and the tan. So off we go. I've got 12 cos squared a, rearranging this, is equal to 2a tan a plus 1. Cos squared of a is equal to 1 plus 2a tan a over 12. And what can I do now? Oh, well, sorry, I'm going very slowly because I currently have the dog right next to me trying to get fed second dinner. Right, let's just go back and have a look and see where we want to get to. Well, we know that if there's a cube coming through in here, that if we just back up one step and see where this has come from, the line before this would have been cos of a is equal to the cube root of all that. And so the line before that would have had cos cubed of a is equal to cos of a plus 2a sine a on 12. Now, you don't need to write all of that out, but it kind of helps to see where we're heading, right? So what have I got here? Well, I've got cos squared of a, but I haven't got cos cubed of a. In here, I've got 1 plus 2a sine of a over cos of a over 12, which is equal to cos of a plus 2a sine of a over 12 cos of a. So what I've done here is I've just got a common denominator for that. And now we're just about there. So we've got cos cubed of a is equal to cos of a plus 2a sine a over 12, which gives me cos of a is equal to the cube root of that. I bet everyone's stopped watching now. Never mind. And then a will be the angle whose cosine is this. So there you go. So I don't think it's that hard a question, but I think there are a couple of things in there that if you don't see them, it is harder. I mean, the first one, again, is just noticing that cos squared of x is a sec squared of x. Otherwise, you're going to have a mucky quotient rule thing here to work with. And then the next thing to notice is just noticing that cube root there, so that realizing that the expression you end up with right near the end must be a cube and not a square root. And again, noticing that you've got cosine and sine, not sec and tan. So you need to undo those trig functions to get back to your basic ones. Okay, Andy, great question. Thanks for sending it in. Guys, please keep sending questions in, and I'll just do them when I get time in the next week or so. So I have my laptop with me, and I have a wee bit of time to do some revision stuff. Thanks for watching.